This is my CA2 for Data Analytics batch gradient descent. So, like the others, it still has the same steps to take to find the minimum squared error from our two data sets. So, first off, we have one of the differences between the standard gradient descent and batch gradient descent is we actually have a list of step sizes to take, and each time we're slowly decreasing the step size, which can, as a result, if our sum of squared errors is very large, then our gradient is going to be very large. And then sometimes if we go from a large positive to a large negative, this is called bouncing. So it's also quite time consuming, this method, so it's not very efficient compared to stochastic. So what we're doing is we pick a random starting point, which is our V, and then the next step is to calculate our gradient. So in our while loop, we're calculating our gradient, we're passing in the sum of squared errors, our random point, and our step size. So then for the next step, then we need to take a step in the direction minus the gradient, which then brings us, we're taking a step in the direction minus gradient because we're trying to find the minimum, not the maximum, sum of squared errors, so in this, we're passing in our random point, our actual gradient, and our step size. And then for step sizes, so this will just iterate through our step size list. Then we're setting our next v to the minimum next vs, and our key is our sum of squared errors. So then we're saying if the distance e, which is our function here, we're passing in our two lists. So we're passing in our random point and our next v, which is coming from here, which is going to be the minimum next vs after taking the step in the direction minus the gradient. While it's less than our tolerance, which is this number here, then we're going to print our where the minimum occurs, which is our next v, and then what the minimum is, which will be the minimum sum of squared errors. So we're calling our sum of squared errors function, and we're passing in our next v. Then we're setting v to our next v, and if while it's still true, we're iterating through that again. And this will be our output. So I ran the file before just because it takes so much time to iterate through and it's not quite efficient. So you can see that this is the point at which our minimum occurs at, and now we're just waiting for, okay, so the minimum occurs, this is our random point, and this is where the point at which our minimum occurs, and then the minimum sum of squared errors is 13,196.62.